All right. Hello. Grade. Is this grade 12, eh? Grade 12. Grade sweet 12. I'm sorry, guys, that I tend to always delay our time together. Simply because there's other pressing matters that tend to call upon my attention. I'm very sorry. Otherwise, I hope you are well. I hope you had a good day. I hope the day was really something special, something memorable, something you can remember. You guys are the most amazing and special people that grade 2025 will have, because you are officially the next group of people will be looking to for next year this time. Next year this time we'll be talking about the release of your results, your grade 12 results. And then don't you forget that, don't you forget that. This coming week is going to be a special week where results are going to be announced, and grade 12s will have their results that they've been waiting for a very long time. So you guys will be in the same position come next year. So what we need to do is ensure that we don't leave any stones unturned when it comes to the maths content. We need to really do what we need to do best. Okay, finishing the book indeed. So as we start today, I just want to quickly check. Yesterday we started what was that topic, Kanene, that we started yesterday? It was the sum to infinity of a geometric series, and basically I gave you some work to do, and I guess I was wondering if there were any specific problems that people felt they'd want to be addressed, or we actually found the work quite manageable, and therefore we can proceed to sigma notation. So I'm being asked to do C2. All right, so Crystal, I'll do C2. Okay, that's the first request there. C2 noted. All right, so okay, let's go ahead and do that C2. Okay, let's go ahead and get down with the C2. C2. Okay. I'm guessing there's no other suite request, so I will get down with C2. All right. First and foremost, the question, I just want to check out what the question said. The question was simply saying there in C2, in fact, all the questions there for C were saying determine the values of x for which each of the following geometric series converge. So we are looking at the value of x for which the geometric series does what? Converges. Yesterday we unpacked the concept of the series that converges and what are the conditions that warrant a series to converge. All right, so I think we did arrive at one sweet, beautiful conclusion yesterday about a series that converges, and that is a series that converges will have its constant ratio being between -1 and 1. So this here is very, very important. A series that converges will have its constant ratio being between -1 and 1. So the question there specifically that you asked says determine the value of x for which each of the following geometric series converges, and C2 gives us this particular series. Yes, I do. I do. It's in my YouTube channel, Mpume. It's uploaded in my YouTube channel. What we did. Um, so 1 minus x plus x squared. Okay. Yeah, because we did some. Craig, definitely I am, hey? Definitely I am. But I'm energized by the people that attend the sessions. Remember, I like the fact that there's people that are loyal and they continue to attend, so that energizes me in the midst of being tired. But thanks for your concern. I really appreciate it. Thank you so much. Okay, means a lot. It means a lot that people actually like consider that, hey, this guy is always pushing here. So and is like doing it just like that freely. And so yeah, I thank you. I appreciate that. I appreciate the heart of concern there. Thank you so much, Craig. Anyways, 1 minus x plus x squared minus. So this is obviously going to be what type of series? It's going to be a geometric series. 1 minus x plus x squared. So what we are going to do here is we are going to simply first and foremost calculate the what? We're going to find the ratio in terms of x. So the ratio in terms of x minus x, which is term 2 over term 1. Okay, which gives us what? R is equal to negative x. Okay, did you at least get that part, my beautiful friend K Crystal? Did you get that part? We're able to calculate the ratio. Ratio is equal to negative x. Okay, case 1 was able to. I'm hoping K Crystal was able to do so as well. Okay, because that's where we needed to start. Then after that, for geometric series that converges, we then need to, in the place of r, substitute that negative x. So we have just done a what? A substitution, okay, of negative x, because that is the constant ratio in terms of x. We have substituted it where? In the place of r. Why? Because any geometric series that converges will have its constant ratio being between -1 and 1. Then what do we have here? A compound inequality. Compound inequality is the type of inequality that we did in grade 10. So we are going to find the values of x as an inequality. So -1 less than negative x less than 1. What is our goal? We want to isolate x and it must be positive. Currently, what do we see? The x is negative. So what do? We divide the negative x by -1. But what we don't do that only here. We do it here and we do it everywhere, basically, where there are the terms. Then negative divided by negative gives us what? Positive x. All right. The inequality sign direction changes when we divide by negative. Positive. So both the inequality signs will change direction, both of them. Okay. If you look at the direction of the inequality signs, they were looking this side. But the minute you divide by -1, what happens? The inequality signs change what? Direction. So even here, as I divide by negative, my inequality signs should be changing direction at that moment. I hope you guys understand what I'm saying. The inequality sign changes direction the minute you divide the coefficient of x by a negative. So there you have it. Then what's 1 divided by -1? It's -1. What's -1 divided by -1? It's +1. Now I'm sure you can see what you see here. You see this -1? We write it on the left because it is the smallest number. You see this +1? we write it on the right because it is the greatest number. Then look at this sign. You see this sign? It was opened. It's like the mouth of a crocodile was opened towards the X. So the mouth must still be opened towards the X for the negative 1. Do you see that? The mouth here is opened towards the 1. So still the mouth should be open towards the 1. Okay, then that's our final answer. Yes, K Crystal, my pen can be erased. Surprised? Surprise, surprise. Surprise. Yes, definitely it can. That's how I roll. I don't roll, yeah. And I can thank my significant other for doing that. My wife helped me and assisted me in getting these types of resources, you see. So I'm very blessed there. So there we have it, guys. Do you see that? That is the values of X for which the series converges. Okay. So just one more time. Okay. First and foremost, the question was saying, for which values of X does this series converge? This geometric series. For which values of X does this geometric series converge? So what do we have to first do? We look at our geometric series. We calculate the constant ratio. That means term 2 divided by term 1. Negative X divided by 1. We get R is negative X. Are we together so far? After calculating the constant ratio, we were asked to find, or for which values of X does the series converge. We learned something yesterday, that a geometric series converges where the constant ratio is between negative 1 and 1. Read or expressed in English, what does this mean? It means where the constant ratio is greater than negative 1 but less than 1. In other words, where the constant ratio is between negative 1 and 1. Okay, does that make sense? Then that's why we calculate the constant ratio. We get the constant ratio and we get it in terms of X, which R is equal to negative X. Since we know that for geometric series, the constant ratio must be between negative 1 and 1, we plug or substitute that X, negative X that we got for our constant ratio in the place of R. And then we rewrite the condition of geometric series. Negative 1 less than, but this time instead of R we are writing negative X because R is equal to negative X, followed by less than 1. Why do we write that? It's because for a geometric series, when it converges, the constant ratio must be between negative 1 and 1. This forms what we refer to in grade 10 as a compound inequality. How do we solve a compound inequality? The whole objective of solving a compound inequality is that in the middle here we must have a variable that is positive. Currently the variable is negative. So then what do we do here? We get rid of the coefficient of X, which is negative 1, by dividing by negative 1. The moment we divide by negative 1, the rule says whenever you divide by negative 1 in a inequality, then the inequality signs will change their direction. So we divide by negative 1, divide negative X by negative 1. What happens? These inequality signs, they change direction. You see, they were looking this way, both of them. Now all of a sudden they are looking the other way, both of them. But when we divide by negative 1, we don't only divide in the middle. That same coefficient, we divide by it for this number on the right and for the number on the left. Then negative divided by negative gives us a positive. 1 divided by 1 is 1. In the middle, we have positive X. On the right, we have 1 divided by negative 1 is negative 1. But then we must write this properly. from smallest number to biggest number. Currently, the smallest number is this side. So we take that -1, we write it on the left where the small number begins. Look at this sign. Its mouth, this is like, I don't know if you guys know Pac-Man, that thing that eats, does, like that. But it's like this is the mouth, it's open towards X. So the mouth must still be open to X. That's why the direction of this inequality sign, as we write -1, we write it in the order that we opened towards X. It's still open towards X. Then this mouth is open towards 1. Same thing, opened towards +1. We rewrite it in this way, and that is our answer. These are the values of X for which the series converges. It's when X is between -1 and 1 that the series, this one, will converge. Okay, I hope you understand. This is grade 12, Khani, as you join in. This is grade 12. Okay, any other question? K Crystal, I'm glad I saw you were happy. All right, and you know what's funny? I think for most people, the problem is not with anything else but with the grade 10 content. It's not that like we don't understand what geometric series and what the condition is, but it's solving the compound inequality, which was a concept covered in grade 10, which basically we need to just make sure now that we still remember and we can still apply. But if you are learning this for the first time, then you must know that this is a compound inequality that you would usually solve from this step downwards. This is a compound inequality that you would solve in the grade 10 syllabus in mathematics. Okay, right. Any other questions, or can I move on to sigma, the next topic? Any other questions from the homework? Or let me not say homework, the game challenge. Okay, or can I just move? Okay, backlit savage. Backlit savage, my goodness. Where do you guys come up with these names? Sure. Right, I get my name is also weird. Maths is a game, but yo, backlit savage. My goodness. All right. Quantum entanglement. Look at that. Quantum entanglement. What the? Molo appeal. Go ahead. You can ask your question. Quantum entanglement. Let me go to C6 because K Crystal also wants C6, which is fine. I don't have a problem. We will do C6 for you. K Crystal. K Crystal. K Crystal. C6. Let's move on to C6. C6 also has to do with the same type of question. For which values of X does the geometric series converge? Do you go live every day? Grade 11, what time? I don't go live every day. I've been going live every day. But as from next week, I definitely won't be able to go live every day. So I've been going live every day, and the most of the grade 11 term 1 work that I have covered so far is uploaded onto my YouTube channel. So your child or whoever can go on that YouTube channel. They can watch the videos that I've done on the first topic, exponents and surds. And now currently I'm busy with equations and inequalities. I just before I did this session at 9 p.m., I did a grade 11 session on surd equations. And then we'll be doing our last session tomorrow with the grade 11s before I head back to my glorious work. Okay. Quantum entanglement. That is the next section of work that I'll be doing after this one. But obviously it will not be immediately, even in this week, because I'm still busy with what? With sequence and series. So tomorrow, what time with the grade 11s? At 9 p.m. standard time. And with the grade 12s, I'll still be doing it at 10:30 p.m. So that's the time. I hope you are sorted there. If you want to check out my YouTube channel, please go to my bio. You can find the link. It will send you there, and maybe you can check out the previous sessions that I've done. Okay. Yes, quantum entanglement. Let us save the date. Woo! Save the date. Quantum entanglement. Save the date. All right, let's go. C6, because my beloved friend there is waiting patiently for C6. C6 says determine the values of x for which each of the following geometric series converges. Okay, so I have a feeling that okay, Crystal is having challenges with algebra. Okay, all right, and when I do this one, you'll soon realize that it's compound inequalities and also simplification of algebra as per the grade 10 syllabus that you are having challenges with here. In geometric systems, I want to understand the difference between Sn. So Sn stands for the sum of n terms. It's the sum of a number of terms, whereas Tn stands for the term number, the number of terms. Okay, so Sn means the sum of the terms. Okay, whether it's 3 terms, you say it's S3. It means the sum of the first 3 terms. S4 means the sum of the first 4 terms. Sum means the addition. You are adding those numbers to get a final answer. Term number means, you get term 1, that's the term that occupies the first position. Term 2, the term that occupies the second position. Tn is generally meaning the term number, okay, the nth term. And generally speaking, Tn has a formula depending on whether it's arithmetic, geometric. You'll have different formulas to represent the nth term. Anyways, hope that question is answered. Nyansile Wilmore, I think K Crystal must invite herself more and more to those sessions. Okay. That means Apile, your network is not networking. Mine is networking. I have good connection. So I think your network is the one. Usually, sometimes you need to switch off the phone, restart it and come back. Okay, you have to leave TikTok and come back. Sometimes that helps. I don't know if there's any suggestions from other people, but there are certain things that tend to help. Okay, so this is our series. X into x, 7 minus 2x to the power 4 minus x into 7 minus 2x to the power 5 minus plus x into 7 minus 2x to the power 6. I'm sure you guys can see, and then that's followed by minus ... So R is equal to T2 divided by T1. What's T2? T2 is minus x into 7 minus 2x into to the power 5. Do you see that? That's T2, over T1. T1 is x into 7 minus 2x to the power 4. So all we are doing, we are simplifying, right? The relationship between everything here. In the numerator, we have one term, minus x into this. All right, the relationship between this negative x and the bracket is multiply. The relationship between this x and this bracket is also multiply. And then the relationship between the top and the bottom is divide. So here we can actually cancel out things that are common and leave the things that remain. So for instance, if you look at this, because the relationship we have is multiply and divide only, we can cancel this x and this x. What are we left with? We are left with a negative 1 in the numerator, because x divided by x gives us 1, but there's a negative 1 because this negative sign, and negative divided by positive still leaves us with a negative. So that's why I'm saying we are left with a negative 1 for the division of these two, negative x and x. Let's look at this one. 7 minus 2x to the power 5 and 7 minus 2x to the power 4. What you notice is that this binomial bracket, binomial means two terms, binomial bracket, these two things, they are the same, they are common. But what do you notice? There are 5 of these at the top. There are 4 of these at the bottom. So if I cancel 5 minus 4, what am I left with? I'm left with 7 minus 2x, one of them at the top. Am I left with anything at the bottom? I'm not left with 7 minus x at the bottom. So at the bottom, I'm left with 1 and 1, and in the denominator, 1 times 1 leaves me with 1. So the final answer is actually negative 1 into 7 minus 2x. Are you with me? And then what I can do is I can multiply this negative 1 inside the bracket. Because the exponent is 1, I get negative 7 plus 2x. This is my constant ratio, negative 7 plus 2x. Now I am going to stop right there, and I need to get an understanding from K Crystal. K Crystal, do you understand how I got this constant ratio? Because you're the one that asked this question. So this simplification is simplification that is done in grade 10. Okay? Yeah. Where there's multiplication and division, all right? Please, but there must be multiplication and division only. Okay, we can't have in the mix addition and subtraction, a separation of terms. In other words, we have one term at the top and one term at the bottom. So cancellation is possible, all right, if there's 1, 1. But if the situation is there's 2 terms at the top and 1, yabona, that's where cancellation is not possible. We need to first factorize and do other things. So here, x divided by x, we can evaluate. It's negative 1. 7 minus 2x over 7 minus 2x to the power 5 divided by 7 minus 2x to the power 4. There's 5 of these and there's 4 of these. So the 4 disappear and the 4 here disappear as well because they are common. But there's 1 left at the top. Hence we get 7 minus 2x to the power 1. But that 1 is not significant. So even if we don't write that exponent 1, we know it's there. This is 7 minus 2x. We can distribute this negative 1 because the exponent that's here is not 2, 3, 4 or any other number, but it's 1. So we can distribute negative 1. Negative 1 times 7 gives us negative 7. Negative 1 times negative 2x gives us positive 2x. Then, Crystal, you remember that for converging series, the constant ratio is between negative 1 and 1. So where do we substitute this r? In here. Do you see that? Negative 7 plus 2x, we have replaced r with negative 7 plus 2x because r is equal to negative 7 plus 2x. Then we need to have x isolated. There's a couple of things that are getting in the way of x being isolated. The first thing that's getting in the way is negative 7. It needs to go. How does negative 7 go? We add 7 to the negative 7. But what we do in the middle, we must do on the left, we must do on the right. So what does that leave us with? It leaves us with 6, because negative 1 plus 7 is 6. All right. In the middle, we are left with 7 minus 7 leaves us with 0, but plus 2x, 2x in the middle. Are you with me? And then at the end, we are left with 8. So here, what did you do? We add 7. Why did we add 7? It's because to get rid of negative 7, we use its additive inverse, which is plus 7. But we add 7 on the left as well. We add 7 on the right so that we have things balanced out. Here, the 2, which is multiplied to x, is also a problem. It needs to go. So what do we do to it? We divide everything by 2. Divide this by 2, divide this by 2, divide this by 2. What's nice is that this coefficient is not a negative 1, so which means the signs will not change. But if we were dividing by a negative coefficient, let's say it was negative 2x, then the signs would change. But in this case, the signs don't change because we are not dividing by a negative. What does that leave us? What's 6 divided by 2? It's 3. What's 2 divided by 2? We are left with x. And then last but not least, what's 8 divided by 2? It's 4. So backlit Savage was on the money there. The values of x for which the series converges, it's when x is between 3 and 4. Okay, Crystal. Okay. I hope you are understanding nicely and comfortably. Okay. Okay. Are we ready now to move to sigma notation? Or is there any other question with regards to that exercise that people had? Going once, going twice, going 3 times, sold. Okay, thank you so much, K Crystal. I do not at all regret doing those corrections, because remember, there's no shame and we should feel free to ask questions, please. Okay. If not here, then obviously, if you feel like maybe you want to still ask, you can always ask me on the side, and I'd be happy to actually respond whenever I am able to, all right, given situation and schedule. I wonder what Madi Bongs is saying, and unfortunately I can't understand that last part. Wena wopilwa. What's that? Maybe someone who has the gift of interpretation of tongues can tell me there. Sigma notation. Sigma. So they are saying sometimes when we write out the terms of a series, you're yapping all about. That's what he's saying. This guy, you are yapping all about. That's what he's. Oh man, Mati Bongs, you deserve a award in your life, my friend. Thank you so much for giving me an opportunity to laugh and just laugh. Thank you so much. Anyways, so sigma notation, guys. Here we are trying to basically make life a bit simple for us. We don't want to be writing a list of terms and represent a series with just a list of terms. This is just a way of representing, right, a series, and they say it's quicker and easier to write down. So there's this Greek letter, all right, this one. This is a Greek letter, by the way, all right. It's in Greek, it's called sigma, okay, and it's supposed to indicate a sum, all right. It means sum. That's what the symbol sigma means, all right. It's a Greek letter, guys. I hope you understand. So let's just say we had sigma, we had T of, let's say T of K, and then we said K is equal to 1. We have N there. This is actually read, we read it as, so sigma means the sum that we know, ne? Because we've just learned some Greek here, that this symbol is a Greek letter that means sigma. What does it indicate? A sum. So this symbol means the sum, but the sum of what? The sum of TK, all right? The sum of TK. For what? For K ne? From 1 to n. Okay. So I repeat again. This here means, or it reads as the sum of tk, right? For what? For the letter k from where? From where, meaning where do we start? We start at 1 to where? All the way to n. This is the end. Okay, so once again, this is the sum of tk for k from 1 to n. Okay, this is what this symbol or notation reads as. Okay, I repeat, sigma, the sum of what? Of tk for what? For k from where? From 1, which is the start, to bani, to n, which is the end. Okay, so let us look at the application of this thing. It's one thing to sort of like see the symbol, what it means, and therefore what this actually reads as. Okay, so let's look at its application. So a series, any type of series written in sigma notation, a series written in sigma notation takes the following form. It takes the following form. All right. So here we have sigma. In this space where you had tk, you will generally have what? An expression, very important, an expression in terms of a particular variable. Now in this case, this expression is one that is in terms of k, but they can use any other letter, guys. They can use any other variable. All in all, it's always an expression in terms of a particular variable here in this bracket. So it's always the sum of some sort of expression in terms of a particular variable. So let's just say it's in terms of k. This is just an example. Then we would say for k from where? From the first value. All right. And then to where? At the top, where we end, the last value. Okay, very important. Okay, very important. So let us then look at an example. Here is a sigma. What do you see here? 2k is a expression. It is in terms of k. Then here at the bottom, we have k is equal to 1. For k, where do we start? At 1. Then at the top, this is where we end. Where do we end? At 5. So if we were to write down the series that basically comes from this sigma, what do we say? We take the expression, which is 2k, but remember, where do we start? We start from 1, which means we substitute in the place of k for the first term. We substitute 1, okay? For the second term, we substitute 2 in the very same expression. For the third term in the series, we substitute 3. The next, 4. The next, Where did we say we end? Up until 5. Are we getting this, guys? Are we together? This is me utilizing the sigma to use the expression, substitute values starting from the value for that particular variable to the end, which is 5, which is why we end with substituting 5. That would be practically our last term. We can add all of these numbers. We can get the actual sum, because sigma is about calculating the sum of a particular expression starting from a certain place to end at a certain place. Do you guys know what 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5 gives us? It gives us a beautiful number, 30. Okay, thank you very much. Okay, Junior, I see what you're writing. Remember, we are just starting out with the basics here. We are getting into the concept. All right, so we will get where you are actually leading us to, but for now we want to unpack the concept one by one, line upon line. Okay, so we get what you're saying. Let's look at this one. 2 to the power k minus 1. Oh, thank you. Here's another thing that I want to say. This expression is a linear. Do we all understand when I say linear expression? I hope you understand when I say this is a linear expression. Linear expression. Look at this one. 2 to the power k minus 1. This expression, what type of expression is it? It's a exponential expression. Okay, so once again, if we look at this one, the sum, where do we start, guys? Where do we start? For k is 3. Where do we end? For k is 7. So when we substitute 2 to the power 3 minus 1, we don't say 1 minus 1. We don't substitute 1, we substitute 3. Because where do we start? At 3. We add 2 to the power 4 minus 1 plus 2 to the power 5 minus 1 plus 2 to the power 6 minus 1 plus 2 to the power 7 minus 1. Do we go on? No, we don't go on. Why? Because we start from 3, we end at 7. And then obviously you guys will be able to also get the answer there. What do we get? Okay, obviously 2 to the power 2, that's 4. 2 to the power 3, that's 8. 2 to the power 4, that's 16. 2 to the power 5, that's 32. And 2 to the power 6, that is 64. You add everything. What do you get? 124. Feeling it? I hope we are feeling it, guys. All right. Let's look at another type. Do we see this one? The sigma, all right, so it's the sum of I squared, where for I is equal to 3 to 4. So what do we do here? In the place of I, we are going to substitute 3 first. Then we are going to follow it with 4. And that's where we end. So then our answer will be 9 plus 16, which gives us 25. The sum of all of that is 25. Let's look at another one. Okay. R is equal to 1, where we have 1 to 20. So let's look at this one. And we can see that the sum is one where there's a constant, but we are starting at r is equal to 1. We are ending at 20. Okay, remember Backlid Savage, we always start with the simple so that we can build up to the complex. Remember, what are we trying to do here? We are trying to just hammer in the concept of the fact that there's an expression, there's a value where we actually start, the first value, and where we end. All right, so that we can actually have a build up that is nice and logical and simple. Okay, now remember, for a constant 3, all we are doing, we are starting from 1 up until 20. So that means we have 3 plus 3 plus 3 plus 3 plus 3, all the way from the first term 3 all the way to how many terms? To 20 terms. So we can say here to 20 terms. Okay, yeah. So for a constant, we simply check from 1 to 20. In other words, there's going to be those terms up until 20 terms. So we just list, because there's no r here, all right? We just list, okay, those numbers, and this simply is what? 3, there's 3 20s. That means 3 times 20, which simply means that our sum is 60, okay? Yeah. All right, so be wary of when there's a constant, okay? Be wary when there's a constant. All right, so that is sigma in simplicity. Now let's look at calculating sigma values by using the formula. And this is where it gets a bit exciting. Remember what we've learned just now? TK, the expression for what? For k from 1 to n. We can calculate sum of series. How? 1, expand the what? The series. 2, use appropriate formula. And I'm going to just highlight the formulas and how we can actually understand those formulas from what we see. So here's an example that we can look at. Underneath this, calculating sigma values by using the formula. If we are given this 2k minus 6, k is equal to 1 all the way to 10. Let's look at this one. So obviously, you guys know 2k minus 6. The expression, let's start there. What type of expression is this? This is a linear expression. This kind of reminds us of something that we refer to as a linear sequence. And a linear sequence here in grade 12, we refer to as an arithmetic sequence. So linear expression, this one, which gives us undertones of what? We did linear sequence when we were in grade 10 and 9. But linear sequence has direct relationship now to arithmetic sequence. These are one and the same thing, linear sequence and arithmetic sequence. But since we are dealing with sum, then we know this has direct relationship to arithmetic series. This is so important. Okay, this will benefit and help us when we have to use the appropriate formula. So the first step now we are going to do for this, we are going to expand the series. But do you understand why how I got to understanding which appropriate formula, and I'll get back to it when I have to identify the formula. So first step, let us expand. What are we expanding? We are using the expression 2k minus 6 to do what? To find the terms of the series. So let's rewrite this thing. K is equal to 1. We know it ends at 10. We have 2k minus 6. Now, let us see the terms. 2. What are we substituting first? In the place of k, 1 minus 6. Together? I hope so. Plus the second one, 2 into 2 minus 6. The next one, plus 2 into 3 minus 6. Hopefully you guys are getting this very well. And obviously we'll say plus plus plus. Too many terms that we are going to be having in that series from 1 up until the 10th term. So we are going to hold our horses, and if we want to calculate the sum of the entire thing, we can just go ahead and understand which formula applies. So we've expanded the series only up until a limited extent, all right? So we've done the expansion. Expansion, check. What we need to check with the expansion, did we substitute first this value for the first term? Yes, check. And did we follow it with the consecutive numbers, 2, 3? Yes. Up until 10, well, we just did a limited series so that we can be able to use a particular formula. Now, choosing the formula depends on this conclusion I made earlier on, which was what? What conclusion had I made? I made the conclusion that this is a linear expression, which speaks to a linear sequence, which translates into arithmetic sequence. And seeing as though this is a series, we know it translates now into arithmetic series. Are you with me? So I know that this is arithmetic series. To find the sum, guys, to find the sum for of n terms for an arithmetic series, do we still remember the formula that we use? Formula sheet will be there, but in case we have forgotten, for arithmetic series, this is the formula. Okay, all right. Now we need A, we need D, and we need N, all right, which is very important. And so there's something that someone said earlier on which will be very helpful in this. Okay, so for A, what is the A value here in this series? That means that's our first term. Okay, so that means we're going to have to find out what's 2 times 1. We have 2. 2 minus 6. Okay, 2 minus 6, because we want our A, the first term. 2 minus 6 gives us 2 times 1 is 2. 2 minus 6 gives us what? So that we can get the first term. Thank you, Sban. It's negative 4. Now we need D, the constant difference. So obviously we had minus 4 followed by 2 times 2 is 4. 4 minus 6 is what? Negative 2. That is our second term, negative 2. So to find the constant difference, what do? We say T2 minus T1. In other words, negative 2 minus minus 4. I hope that's clear. Then that gives us a nice answer of positive 2. Now, Junior earlier on in an earlier comment helped us to see how we can get the number of terms in the what? In the series. All we do, guys, is we take last value minus first value, and then we add 1. Last value, which in this case is 10. I hope you understand, guys, from the sigma formula. Do you see that? Okay, some people say top minus bottom plus 1. Still, I hope we get the point. Okay, last value minus first value, and then we add 1. Or we can say top value minus bottom value plus 1. So if we say 10 minus 1, we get 9, and then we add 1. Okay, that should give us our n, which is equal to 9. Obviously not, guys. 10 minus 1 is 9, and 9 plus 1 is 10. Okay, so n is equal to 10. Very important how to get n. And I'm hoping that you can see that this is basically the formula we are going to have to use for our sigma. Whenever we're given the top and the bottom value, all we do is we take the top value, subtract the bottom value. We always add this one. Don't forget it, guys. Add the 1. Therefore, it gives us how many terms? There are 10 terms that we actually have to utilize. So let's go now and use and substitute the sum. We are calculating the sum of 10 terms. That means 10 over 2 over 2. What's a? Negative 4. Plus n obviously was 10 minus 1, and the d there was 2. So all of that is in brackets, and we can use basically our calculator and plunge in all of this. Very easy. Okay, you can just punch this all in our calculator and it makes life very easy. So 5 brackets minus 8 plus negative 9 in brackets times another bracket, which is 2, and then we close that bracket. Then we should be able to get the sum of that series. All right, so the sum of the series will give us what value, guys? What do you guys get? Thank you very much, Nuri. Nuri picked up an error. Okay, can you guys see the error that I made there in brackets? Okay, thank you so much, Nuri. So 10 minus 9, 10 minus 1 can't be negative 9, guys. Okay, so there we go. Thanks to my pen and thanks to Nuri. Okay, I substitute that, and I'm sure you get a nice, beautiful answer. The sum of the 10 terms is 50. Okay, let's look at another example. All right, another example. Okay, so obviously there we could see that is a arithmetic series because of the expression. Let's look at another example. 8, we've got I is equal to 1. We've got 5, we've got minus 2, we've got to the power I. Do you see that, guys? Yonkinto inexesha layo, hey? Okay, so let's start. Let's go. First and foremost, what do we see? 5 into negative 2 raised to the power I. Okay, if we look at this expression, what does it give us? Okay, we get exponential expression. But if the unknown is an exponent, which sequence kind of gives us that vibe? Okay, where the unknown is an exponent, that speaks to geometric, very important. And more specifically, since we are dealing with sum, we are actually dealing with a geometric what? Series. So do you see, guys, how I am able to get quickly? I look at the expression, that helps me establish what type of series I'm dealing with because of the expression after sigma. All right. The next thing that I can then do is expand, because that's the first thing I actually am supposed to do. So let's expand this thing here. First, we substitute 1. 5 into minus 2 to the power 1. We follow that up with 5, negative 2, 2. Follow that up 5, negative 3, negative 2, sorry, still 3. Okay, sorry guys, sorry. I am so positive that the time of night also affects me very brilliantly. Let's say plus dot 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 plus. Obviously, if we are going all the way to the 8th, we are going to be writing more. So let's just stop. At least after the third term, we are fine. 1, 2, 3. That's 3. That's fine. All right. So now we are going to go and choose an appropriate formula. We learned that this is exponential, which means it's a geometric sequence. It gives us that vibe. In actual fact, since it's a sigma, it's a geometric series. This really has that form of a geometric series. So the formula that we need to use, very important. But before we can locate that formula, what is the value of A? If we look at this, 5 times negative 2, the value of A is negative 10. Since this is geometric, what is the value of R? Okay, so that's 20, as you can see, because negative 2 to the power 2 gives us positive 4. 4 times 5 gives us 20. That's 10. What's 20 divided by 10? 20 divided by 10. Oh, yeah. 20 divided by negative 10. That gives us negative 2. Let's not forget, sorry, that the A first term was negative 10, remember? The next term was 20, that's positive. So 20 divided by negative 10 gives us negative 2. Our R value is negative 2. Then, what sort of sequence, okay, did we conclude this is? Then what sort of series is it given the sum? This is a geometric series. So the formula we ought to use is the one that says S of n is equal to A 1 minus R to the power n over 1 minus R. Why this one? Because this is the one that we use when R is less than 1. Remember that? Remember that? R is negative 2. When R is less than 1, we use this one. So A, oh yeah, and then the last thing, n. How do we find the value of n? Do we still remember how we find the value of n? We say top minus bottom, and then we add 1. Or in other words, the last value over the first value, minus the first value, and then we add 1. So that gives us 8 minus 1 plus 1, which will give us 8. So we have A, which is negative 10. We have R, which is negative 2. We have N, which is 8. We are ready to use the formula. S8 is equal to, what's A? Negative 10. 1 minus R, negative 2 to the power what? To the power 8. When I substitute, people, in a certain variable, I use brackets. Very important. Okay, especially if I can see there's even an exponent, because this negative 2 raised to the power 8, if there's no bracket, will mean something completely different. Okay. I'll be alive again for grade 12, 10:30 tomorrow. 1 minus 2. Then we can simplify this. A negative 10, 1 minus, let's look at what's in the brackets, because bad mass means brackets, exponents. This negative 2 must stay outside. Negative 2 to the power 8, that gives us what? That will be a positive number inside the bracket, but the 2 to the power 8 is an exponent. That gives us 256. Okay, and we can remove that bracket. That's 1 plus 2. And I mean, we can punch this all in the calculator. So let's just do that. Punch everything that we have there in the calculator. So we have negative 10. We use the, okay, let's just do this. Negative 10 at the top. We put that bracket. We have 1 minus 256. We close that bracket. We divide that by 1 plus 2, which is 3 in the denominator. Then we say equal. There it is, guys. We get 850. Thank you, South African vibes. So S of 8, simply put, is 850. Nicely done. Then let's look at the last one. Just so that we can explore the various sigmas that are there. Now you can see with this one guys, see this one, hey, this one, 2 brackets 4 to the power 1 minus r, right? What vibes does this give us? Exponential with an unknown in the exponent, okay, but this must be geometric. So once again we have geometric series. From the expression, we know we need to form a geometric series. Where do we start? At 1. Okay, but to infinity, hey, to infinity. Now this is very interesting. So yes, backlit savage, I love this, I love that. You see, people are coming in here. To infinity means this time round, the formula we are going to be using, it's definitely not going to be, it's not going to be our arithmetic series formula for sum of a number of terms. It's not going to be geometric series for the sum of n terms, but we are going to be using something completely different. Why? This is what we call an infinite geometric series. Why? Because there is no end. This is the start, but infinity means no end. Okay, Tandega Mahlangu, you go on to my bio. There's a link that's there. Okay, go on to the bio. There's a link that's there. Click on the link, the YouTube link. There are 2 links. There's one link that's the WhatsApp channel, where I tend to upload like not videos, but I tend to upload past papers and other like questions and stuff for different grades. Go to the YouTube channel, the second link. Okay, maths is a game, 5 to 7. You should find it, man. Come back again and let me know if you are able to succeed. Okay, so I was saying this is an infinite geometric series because of the end. Okay, it's infinite, whereas this one, it was not infinite, it's finite. There's a beginning, there's an end. Here, there's a beginning, no end. How you see? So let's go anyways. A, what is our A value? Our first term, 1 minus 1 will to the p to the power 0. 4 to the power 0 is 1. 2 times 1 is 1. So A is equal to 2. What about R? Okay, remember A is the first term, guys, right? So 1 minus 1 is 0. 4 to the power 0 is 1. 1 times 2 is 2. That's why A is 2. Now, we want to find R. Okay, and for a geometric series, it will continue to be T2 divided by T1. Okay, we know this is 2. The following term, 1 minus 2 gives me 4 to the power negative 1. 4 to the power negative 1 is 1 over 4. And 2 times a quarter gives me a half. So So I have 2 plus half. So T2 is half. T1 is 2. Half divided by 2 gives me a quarter. So my R is a quarter. Well done, Thandeka Mahlangu. Well done. Well done. So A is equal to 2, R is equal to a quarter. Hopefully we understand how I got those values. It's a matter of finding the first term, all right? That it's 2. The second term in my series, I find it out, it is half, okay? Then obviously, the constant ratio is T2 divided by T1, a half divided by 2, which gives me a quarter. Now, all I need to do now is find the sum to infinity, okay? So I'm not concerned right now of finding n, y, because I'm not dealing with a finite geometric series. I'm dealing with an infinite geometric series, guys. So it's sum to infinity because of this guy. All right. Then we can proceed and say A over 1 minus R, because this is the formula for sum to infinity. Okay, we learned about this formula yesterday, and if you want to see how that formula is covered extensively, the teaching of it, you're more than welcome to go to my YouTube channel and watch the previous videos that I've done so far. Then A is what in the numerator? It's 2 over 1 minus the R. Substitute that, a quarter. And guys, calculator is always the way to go, man. Sometimes we are so lazy to do these things, so we go to Mr. Calculator. He does not give us hassles. We do not give him hassles. Just plug that in. Booyaka. 8 over 3. Booyaka. 8 over 3. Our answer. So we know sum to infinity is 8 over 3. Okay. So people, this is us constantly finding or evaluating. There's many situations where they say evaluate the following or evaluate this sigma. So these questions that we've just done is where we are calculating the sum of the series. It's where they simply give us the sigma and they just say evaluate it. Oftentimes they'll say evaluate it, and there's just an expression, and you have your first starting number and your last. Okay, yeah. Whether it's arithmetic, geometric, or sum to infinity, you will be able to see as per the scenario and as you study out the expression. How important it is to know the different types of expressions. Now I'm sure you guys can see why it is important to find the different types of expression. And then also, how do we go about finding what? The value of n when it is not known. All right. I just want to look at one more. All right. At least a situation in this case where k in the bottom is not the characteristic 1, because we've been looking at a lot of scenarios and k has been 1. Okay, let's just look at this one, and obviously this one specifically, I'm sure you can look at the expression. If you look at the expression, what type of series? Let me just see in the comment section if people can conclude what type of series this one would be, given the expression 2 brackets 3 raised to the power k plus 2. Nuri says geometric. He says geometric. Backlit Savage says exponential. But what series specifically then, Backlit Savage? I love that you said exponential. This is an exponential. Exponential alludes to which type of series in this case? Yeah. Okay. I think we all get this thing, which is good. Then what do? We must expand. We must expand. Remember, 2 here is the start. It's not 1. How important that is. So 2 times 3, we are going to write not 1 but 2 plus 2. Why? Because we are starting at 2. Does that make sense, guys? I hope it makes sense. Then from 2, we follow it up with the next value that follows after 2. It's 3. And the next value that follows after 3. Alright? And you get the point, ne? Let's say here there was k is equal to 7. Then obviously we would write our first value, our substitution for k would be 7. And then we write the consecutive numbers, 8, 9. I hope you get the point, guys, because if we get that, then we'll be fine. 3 to the power, 2 plus 2 is 4, 3 to the power 4 is 81. 81 times 2 is 162 plus. Then we go to 3 plus 2, we have 3 to the power 5. 3 to the power 5 is equal to 243. 243 times 2, that gives us 486. I'm just wanting to find the first two terms at least. The evaluation of those terms. I mean, the rest is fine. So now we know we've got the value of A. Hopefully, I'm sure we can see the value of A in this situation. Okay. Value of A in this situation. Oh, there's something here that I did that I shouldn't have done. Okay, please, guys, can you entertain me here? All right. Can you entertain me here? Allow me to do this, please. Okay. Please allow me to do this. We are starting at -2. Let's make it a bit more interesting. I'm just thinking as well that it will also be something new for us, but it will also help us to learn, because all the values that we've had to start with have been positive values. So let's just check for a moment if k is a negative value, all right, so that we can learn what we need to learn. So obviously our first starting value, if k, remember, is a negative value, k is -2. Okay, do I tutor? Yes, I do. So you substitute -2 in the place of k, you follow it with +2, right? Then after -2, what follows after -2? Can people tell me what follows? What is the consecutive value after -2? This is always interesting for me, what people say. What's after -2? Oh, you guys are phenomenal. Thank you for giving me the right answer, because it's always funny for me when people say after -2, -3, and I'm like, come on, guys. We're talking about increasing consecutive numbers here, increasing consecutive numbers. So very good, guys. -3, you never disappoint. So -2 plus 2 gives you 0. 3 to the power 0 is 1, and 2 times 1 is 2. So that's our first term. The next one, -3 plus 2 is -1. 3 to the power -1. 3 to the power. You see, now I'm saying negative, but you said -1. Sorry, guys. You see, I am making the mistake now. -1 plus 2, sorry. -1 plus 2 is +1. 3 to the power 1 is 3. And then 3 times 2 is what? Is 6. You see, I am the one making that mistake. So I'm the one who is got my bearings off here. Thank you so much for fixing me in the comment section. I really appreciate you. You are amazing. High five. Okay, so that's our first term. That's our second term. So A is equal to 2. We good? Fine. R is equal to 6 divided by 2. T2 divided by T1. Remember, T2 divided by T1, which is equal to 6 divided by 2. What's 6 divided by 2? It's 3. Got it. Then we need to find n, remember? Now, what did we say? How do we find n? I see Backlit Savage, you've already maneuvered to find what you think is the answer. Let us wait and see if it is what you say it is. Do you remember, guys? What do we say when we want to find n? We say, very good, Nuri, 6 minus the top, add 1. 6 minus, what is the bottom number? It's negative 2. So it's 6 minus minus 2 plus 1. Now, what's a negative times a negative there? We have 6 plus 2 plus 1, which gives us 9. Very careful with the signs, guys. Top minus bottom. The formula already has minus. So if we are substituting another negative number, that means there will be a sign multiplication, which gives us positive. Be very careful here, guys. Otherwise, if we are not careful here, just marks, they go down the drain if we are not careful with our signs. Okay, very important. You see, South African vibes is saying something else different from Mr. Savage. You could say that it's a Savage and South African vibe affair. Then the formula that we use is which one? It's a finite series. It's geometric in nature. So we use the geometric sum of n. But which one? R is equal to 3. R is greater than 1. So we use this one. R to the power n minus 1 over R minus 1. This one we use when R is greater than 1. Okay. A2. R3 raised to the power what? Remember, it was the sum of 9 terms. 3 to the power 9 minus 1 over 3 minus 1. Here I'm just going to grab my calculator and substitute and just get the answer. See the brackets? Please, people, the brackets as you see them is what I'm definitely going to punch into my calculator. 2 brackets, 3, close brackets to the power 9. There it is. Minus 1, another bracket, closing. Okay, let's be careful there. We don't want to see ourselves writing that minus 1 in the exponent place. Minus 1 at the bottom, please. Close bracket over 3 minus 1 equal. There we go, the answer, 19,682. So I see Savage basically gave way to Vibe's answer. And there we have it, guys. There we have it. Think we can actually move nicely there and do these calculations smoothly and nicely without real major hectic problems. I think we can. Take into cognizance what we've been learning. We should be good. Okay, we should be good. Yeah, you was correct, definitely. I want to look at another type of a problem. This type of a problem is the type when we are actually asked to find the top value. Okay. What do we do when we are asked to find the top value? And in our sigma formula, okay, we are given things like this. So we asked here to determine the value of m. Okay, so here we are saying when the sum, this is the sum, this is usually we were finding the sum, but when the sum is given to us, okay, we can determine the top value, okay, in the sigma notation. How? By first solving for n, okay, and then using the formula n is equal to top minus bottom plus 1. Okay, so in this case we are being asked to solve for m. Okay, So we want to determine the value of m, which is basically where our n would be, right? Yeah, the top or the end last value. All right. So where do we start? So here we start simply, right, at this place. We can take the 4. We can go ahead and just look 3 times 4 minus 2 plus 3 times 5 minus 2 plus 3 times 6 minus 2. You get the point. Okay, we get the point. So we have 12 minus 2 plus 15 minus 2 plus 18 minus 2. So if we look up, we actually have 10 plus 13 plus 15. Oh man, not 15. 18 minus 2 is 16. Okay, and obviously we would have plus dot dot dot. All right. Now in this situation, what are we going to do? We're going to use the sum. We're going to use the sum of what? Which formula are we going to utilize? What type of series does this form? Arithmetic. So arithmetic series. So we know S of n is equal to the sum which is 1150. Okay. But what is S of n? It's n over 2 into 2a plus n minus 1 d, which is equal, all of it, to 1150. Okay. Now then I can go ahead and substitute. Substitute what? I can go ahead and substitute my a value and my d value. Okay. So my a value is actually equal to 10. My d value is 13 minus 10, which is 3. N is what I will find, which will help me to go and find the value of m. So I'm going to first start finding n, and then that will help me to find m. So let's go and find n. So we have n over 2. 2 times a gives me 2 times 10 plus n minus 1, and then the d. I usually like writing the d as a number before the bracket because multiplication is commutative, all right, and it's equal to 1150. So first and foremost, I can multiply both sides by 2. Why? Because I want to get rid of the denominator 2. When I multiply by this side, the left, by 2, I need to multiply the side, the right, by 2. So when I do that, what comes out? I get n into 2 times 10 is 20 plus, if I distribute the 3 there, I get 3n minus 3. And then if you multiply 1150 by 2, 1150 by 2, you guys should tell me, what do I get? 1150 by 2, I get 2300. Thank you, South African vibes. Then n into 20 minus 3 is 17, so I have 3n plus 17. Distribute the n into the 3n and the n into the 17, so I have 3n squared plus 17n minus 2300 is equal to 0. All right. Then some people would factorize, but you know, when I look at this and I'm like, number's too big, then I think to myself, let me just use the quadratic formula. Okay, but remember, we are not going to say x is equal to, we are going to say n is equal to. We write down the quadratic formula, we substitute. Remember, a here is 3, b is 17, c is equal to negative 2,300. A is 3, the coefficient of n squared. B is 17, the coefficient of n, plus 17. And then c is negative 2,300. Substitute. Negative, bracket 17, plus minus b squared, that's 17 squared, minus 4. A brackets 3, and then c brackets negative 2,300. Please, when we substitute, guys, make sure those substituting values are in brackets. Into 2a, and that's 3. Take my calculator, punch all of that in. So I have negative, okay, very good, Wilmore, really appreciate it. Let's just play it out for those that have not gotten there yet. So that's 17, we have 17 squared, minus, that's 4, times the 3, negative 2,300, over 2, times the 3, and then we punch that in. First answer is 25. So n is equal to 25. Or we go back to our calculator, we use these cursors to go back. Oh no. Oh no. All in all, we go back, we go and change, because initially we had a plus sign. We go back to our calculator, to that place where there's a plus, we change that to minus in our calculator, and we press equal again, and to get a second answer. And that second answer should actually be negative 92 over 3. All right, this is grade 12. But we know that n is supposed to be a natural number, so n cannot be negative 92 over 3. But the natural number n is equal to 25. That is correct. Okay. Now, let's go back. Do you remember how we would go about finding n? We used to say n is equal to top minus bottom plus 1. Now, n here this time round is 25. M, which is the top number, that's what we don't know. The bottom number in that sigma that we had is what? Is 4. Plus 1. Okay. Then we solve for m. Okay. We solve for m. Now I don't know what is Nell saying. Say, can you please do it again with different number? Nell, you losing me. I am lost there. What do you mean? Different number where? What are you talking about? Nell. This is grade 12. Nell, what are you talking about specifically? Can you do it with different number? What are you talking about? Okay. Yeah, well, hopefully he can comment himself, because he's the only one that knows what he means, really and truly. 25, we transpose the minus 4. You see the m is already positive. Transpose the minus 4. Minus 4 goes to the side, it's positive 4. Transpose the 1, it's negative 1. The m was already positive, right? Yeah. So that gives us 29 minus 1. That's equal to m. Therefore, I'm sure you can see what m is. 29 minus 1 gives us 28. To Yonwaba Makinza, we were basically determining the value of m. We are determining the top value for when we are given a sigma equal to a certain sum. All right, so that's what we were doing. First, substituting into the expression to get the terms of the series 10, 13, and 16. Then being able to, that's what we were doing. All right, and we were trying to find the value of m. So we just did find the value of m, and that's there. Okay. Obviously, there are other types, guys, of questions where we have to determine the values. All right. We just did one that's arithmetic. Obviously, there's geometric as well. That sometimes we have to do. And then the last question I want to address before I call it a night, and I'll use the last 10 minutes. One last one. The last type of question that I want to look at is where we have to write the series that we're given in sigma notation. Can someone who has done this for the year, last year, or someone answer Wilmore? Wilmore is asking, is it possible that a start cannot be given? What do the masses say? Is it possible for a start not to be given in the syllabus that we are doing? How are we going to find the terms of the series if the start is not given? So I want to say no, eh? So here we are always finding the top. All right. Within this syllabus, we are always finding the top. Okay. Because remember, the start number helps us to establish the terms of the series, which basically will help us find A and find D if it's an arithmetic series. Find A and R, So within the scope of the problems that we are doing, within the syllabus that you guys are doing, which is CAPS, okay, there's a limitation, guys. Okay, let's just be outright. There's a limitation within the scope of the work that you guys are required. All right, so we are always, or let me say, we will be given questions within the scope of finding, all right, that top value, okay? Because that's what they examine within the scope of the syllabus that you are in. Whether that is possible or not is another thing, but we are looking within the scope of what we are covering within the syllabus. They are limiting you because obviously there's advanced mathematics that you can do if you want, where you can explore further and further boundaries and borders, of mathematics. So don't worry, don't worry. Yeah, that's basically how it is. Limitations are there everywhere in maths. In grade 10, you are limited. You can only do up until a certain point. 11. Likewise, 12, you are limited. You go to varsity, you explore others. So if you want to do maths further, then don't worry. There's a place for that exploration even more. Okay? But unfortunately, here we have limitations. So I didn't say, please don't get me wrong, I didn't say it's not possible. But I just said we have limitations within the context of the syllabus, okay, that we are given. So I said we want to see how we can write the series in sigma notation. So if we're given a series how can we then write this series in sigma notation? Does that make sense, guys? So in other words, if you think about it clearly, we want to find the expression, all right? So if it's arithmetic, then it means we want to find Tn. To do that, we would obviously use Tn is equal to a plus n minus 1d. Then we can find the general term, which will be the expression here. If it's geometric, we want to find Tn using a r to the power n minus 1, which will fit here. Then we want to check from the first term, where are we starting? And then we want to check where we are ending. Okay? Hopefully we can see this, guys. All right? Yeah. So this is very important. So first and foremost, let's look at the terms of the series. -3, -7, -11, -15. This is giving me arithmetic series vibes. Okay, so we have a, which is -3. We have d, t2 minus t1, which is -7 minus -3. So it's -7 plus 3, which is -4. Wow. So the first term is a is equal to -3. The constant difference, the reason why I'm saying this is arithmetic, I'm not told what type of series it is, but I can see the formation of the terms. Okay, from -3 to -7, from -7 to -11, the progression of the terms, okay, shows us here that we have a constant difference. Okay, yeah. So we can go ahead, guys, we can go ahead and find Tn, the general term, because we know how to find Tn of an arithmetic sequence. So we say Tn is equal to a -3 plus d. Remember, I said I like placing d first and then following it with the binomial expression. So that's -3. Positive times the negative is -4 into n minus 1. Then I can distribute that -4. -4n plus 4. I have -4n. The constant terms, if I add them, -3 plus 4 gives me +1. Please take note of what I did here. This d and n minus 1 are multiplied together, which means this is a product of two things. And the multiplication is commutative. I can swap, d can come first, so the -4, which is d, I can write it first, multiplied by n minus 1. At the end of the day, I know I need to distribute by multiplication this -4. Positive times the negative gives me -4. That changes the positive sign. -4 times n, -4n. When I multiply, they combine. -4 times -1, negative times the negative is a positive, and 4 times 1 is 4. Okay? -4 times n is -4n, negative times the negative is positive, and 4 times 1 is 4. Then the expression -4n, what's -3 plus 4? I get +1. So this is Tn. Okay, we're getting there. Now we have the what? That expression that we are supposed to place next to sigma. There it is. Okay. Then we are not done. The next thing we want to do is actually find the value of the top end. Where do we end? And we know where we end is n. We were given in the sequence the last term of the series. Now, if we take Tn and we equate it to the very last term of the series, then Tn we already know it's -4n plus 1. We equate it to -123 because we are given the last term of the series. Tn is equal to the last term. This will give us the position of the last term, but it will also give us an indication as to how many terms there are in the series. If we find out that this is the 15th term, that means there are how many terms in the series? 15 of them. Okay, I hope that makes sense. So negative 4n plus 1 is equal to negative 123. We solve for n. We transpose the 1. We get 4n. Negative 4n is equal to negative 124. Then we can solve for n here. Divide both sides by negative 4. Okay, we get n is equal to 31. Yeah. And I would say we are now sorted. So our sigma notation is the following. We have an expression which we are going to use k to use. Just use k, just another variable. Remember, we were using k anyways that other time. So we're just going to use k. Alright, minus 4k plus 1. That is the expression. We got it when we found the general term. Where does it start for k? Alright, when we substitute 1, negative 4 times 1, we get negative 4 plus 1, we get that negative 3, which is the first term. Okay, so that means k is equal to 1. Then at the top would be 31. Okay, remember this is for k. We start at 1, we end at 31, meaning when we substitute here in the position of k, we start at 1, we end at 31. This is not the value of the last term in the series this year. This is the value we substitute in the expression to get the last term. So when we substitute 31 in this, we should get the last term. So let's not confuse it, guys. That negative 123, all right, is the value of the last term. This is the position of the value of the last term. So this top number represents the position of the last term, whereas this represents the position of the first term in our series. Please, guys, let's not confuse that. Okay. Hopefully it makes sense. Hopefully it makes sense. Okay. Right. So this is our sigma. Done and dusted. Who would have thought? So good people, I'm going to end right there. Okay. We've looked at those types of problems that have to do with sigma notation, and all of them are valuable. I'm happy, K Crystal. I'm very happy. It makes me happy when you are happy and you feel that it's good. It actually, in fact, it just makes me happy generally when people feel that it gradually makes sense as one bit at a time. All right. So then what I would ask you to do is to then please do the following challenge questions for yourself. All right. So that you can hammer these in. Yes. Those are coming up as usual. You're welcome, Wilmo. You're welcome. You know, Moss. You're welcome. You are very welcome. So the first question here that you're being asked is evaluate the following. So please evaluate these ones. This is 1 to 10. I can see people like 2. Okay. I'll go back to that first page as I'll go back just now. Let me just show you the game challenge problem so that you can do for homework. All right. Then these are the ones that follow. Okay. 2, 5, 8, 11, 3, 6, 9, and 12. Yeah, let's do these, guys. Please, if we do all of them, then yeah, we'll begin to feel that, oh, okay, no, it's not too bad, this thing. Okay, yeah. And especially if we are going to be continually referring to what we've done as a point of reference. Okay, yeah. Then let's go. Then these are the next few. Determine the value of m. You see, these ones are determining the value of m, the top value. See, top, 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 top. All of these are requiring you to determine the top value. And then last but not least, write the following series in sigma notation. Okay, these are the first few. Write the following in series in sigma notation. 1, 3, 5, 7. Okay, then on the other side we have write the following in series in sigma notation as well. 2, 4, 6, and 8. And then last but not least, you have these last two, D and C. For which values of x of the geometric series converge, calculate the value of p. If this. Okay. If you're done and finished for some reason those problems, I'm more than happy to send you, if you want, the memo, even if you want me to send you the memo for the questions that were previously done. Okay, I didn't do these ones. I did write the following series in sigma notation. Okay, but obviously this part, this sequence, I did this one, but this one was geometric. That's C, this one. Okay, writing the following series in sigma notation. All right, you can just check it out. And then last but not least, this one was to write the following in sigma notation, but it's a to infinity one, sum to infinity. It's also pretty much the same method, but it's just that obviously at the top you are going to have infinite. K is easily going to be 1, no problem, and it's just a matter of getting Tn using the the Tn is equal to AR to the power n minus 1 for geometric series. Okay, yeah, so hopefully you can see that. Right, I just wanted to also show you the other one that I did not do, which was this one, but that's also okay, where you are supposed to find the value of what? Of m. Okay, but they said it's less than 3,400, but that's not a problem. Okay, now we're not going to be bothered with trying to find the inequality. We're just going to, when we come, we're going to first find the terms, of course, by substituting the 2 as usual. Find our a value, because this is geometric. Find our r value, which is 2. Substitute, equate, not less than, equate to 34,000. And then find our value of what? Of n, which is equal to 10. Substitute it into that. N is equal to top minus bottom. You see? Top m minus bottom plus 1. Then we transpose, we get our answer. We'll get an answer of m should be less than 10 plus 2 will be 12. 12 minus 1 will be 11. Since it's less than, we just say m will be less than 11. You see? Not a problem. Not a problem. So we just revert back to less than at the end, where m is an element of natural numbers. So there's nothing to this thing if we have less than, you know, nothing. So I'm sure you saw in the other questions, there were these questions where there was an inequality sign. There's nothing in that thing, guys. We're still fundamentally following that method. Okay. Okay. Okay, let me go back to the other notes for the purpose of who was saying I need to. Can I see the first one, please, Mpumi? You mean the very first thing that we did, Mpumi? Is that what you're saying? And then, I appreciate your comment, K Crystal. I saw that. The fact that you said it's interesting that I do this. Yeah, and I appreciate the words. God bless me. I really appreciate that. Yeah, I give glory to God at the end of the day. Must remember the game work. Oh, you want me? Oh, I was like thinking you were saying I must go back to the first page. I was like, yo, this guy. All right, here we are. This one, evaluate. So these are okay. I don't know if you see it like this. Do you see everything, Bume? Are you able to see like even the little letters? That's why I was like trying to get the at least. Okay, these are the first. Just sorry. Yeah, so these are the first. Yeah, sure. I'm also hoping that you're doing that. Then these are the next. So these are the first ones. These are the next ones. Okay, that's infinity. That's an infinity sign there. Okay, and then the next one is this one. Okay, I'm gonna move down. Are we good? Can I move down? Okay, let me move then. Or have you done these ones? Were you able to take a screenshot for these ones, or do I need to go to them as well? So this one is determine the value of m in each of the following. Okay, so I'm hoping you can see 147258, at least these ones. You can see very well, I'm hoping. Okay, then that's 369. Are you guys in my WhatsApp group for grade 12? Because hey, at least you guys should also be in the WhatsApp group. And hopefully you are. Just because I was thinking I could have probably just sent these a screenshot for you in that page, and that would have been easy. Okay, so you got the other ones. All right, awesome. All right. Yeah, man. Let's do that. Sorry. Maybe it's me. Just okay. So I'm gonna direct. I promise to do that now. Please just send me a inbox message now. When I end this live, I'm gonna go to the inboxes and just I'll do that, Crystal. But those who are not in the WhatsApp group, the Grade 12 WhatsApp group, just send me an inbox message so that I can add you in the group, okay? Or at least get someone to add you there. Just do that now. Send me your contact details. I'll add you. Because initially I thought if I could send the link, it would be fine. But somehow TikTok is doing funny things. The minute I send a link, it just doesn't register. I can't send it. It says not sent, and I don't know why. But I guess that's TikTok for me. Okay, guys, thank you so much. Tomorrow we'll be wrapping it up with our last session. I think we'll be doing simultaneous, and then was it like word problem type, and then that should basically more advanced questions on series, and then that should be it. Okay. Yeah. What about the first page that we did? Yes, man. What do you want? First page, as in like first page of word problems, or the first page of notes that I did when I was writing down? Okay. Is the first page of problems this one? When I started off with sigma notation, Greek letter, indicator, sum, TK read as the sum of TK for K from 1 to N. From 1 to N. And I don't know which one you want notes for, my good friend. What do you want as notes specifically? Please show the bottom. This one. Or you'll tell me to the left or to the right of my notes. What? Some people, they don't sleep, they don't slumber, they are awake. Probably they can say the same about me. I'm not asleep, I'm awake. Yo. Sure. My soul. Okay. They are fighting. Alright. Okay. Good. Sweet. Good. I hope we are good. Alright. Okay. Good people. You are welcome, Span. The light of the world. You are the light of the world. A city that is set on a hill that cannot be hid, Span. Okay, guys. Thank you so much. Let me vamos. It's been a night and a half. Wow. Didn't imagine that I'd be sleeping at the time. Are you kidding me? Okay. Thank you so much. Let me love and leave you. Those, like I said, the group you will send me, I will do my best. Okay, goodbye. Thank you so much, Mpume. Really appreciate it.